Hello there, February 27th, 2024. I haven't finished studying the section 5 of chapter 3, but this proposition 31, it's part of the study of the section to prove the other cases. So since it's a problem, I thought I might as well do it so that I do a correct study of the section. So we have these structures and then map to the complex numbers for each, for instance, lattice and a point of order exact n, etc. And we need to show that these mappings are in one-to-one connection to functions that transform correctly under this guy of weight k, functions on h transforming correctly. At first I thought that it was a formal, just a new formalism saying the same, but I've come to believe that it's actually a very ingenious reformulation that should be understood fully before going on. You see, we just have, there's of course the probability of differentiability, but defining a function on these structures which scale with weight k, and then doing this, and then finally defining f of z to be f tilde of omega z.1, then f of gamma z equals gamma to minus k f of z. That's very ingenious. So it's a reformulation where this just becomes scaling. So first, to prove it, there are various small things. First, if we exchange omega 1 and 2, then we get the same lattice. But you see, omega 1 divided by omega 2 must be an element of h, so we can't just flip them, because then it's mapped to minus h. The reciprocal has negative imaginary part. So that was one of my first small confusions about this function, f tilde. Next, we need to show that we can of course define this way. So we need to show that it is a one-to-one connection. Of course, any time we have a well-defined function, because they do have omega 2 here divided by n does present lattice with an element of order n in C modular the lattice. So I'd like to show that this structure is invariant under these guys. I don't know exactly why I need that at the moment, though. This is obvious. I don't even think they treat it in the book. When we have these guys, they span a lattice, and then we have to show that it's invariant. Oh yeah, that's what we have to show. We have to show that gamma f tilde equals f tilde, which means per definition that gamma operating as a matrix on the column vector changes nothing. And that means we have to show that this element, when we operate with gamma, then it will generate the same S. Now, the coordinates of this is 1 divided by n. Naught, comma 1 divided by n, and it gives b divided by n, d divided by n, This is really strange. To make it invariant under, it should actually be the first guy. You see, if we are in gamma n, then B and C is equivalent to naught modulo n. Which means that these are integers, so they actually lie in the lattice. L omega. That takes care of this, of course, but in this case gamma naught, that I was actually thinking about, then this may be anything, and this is equivalent to 1 divided by n, but then we get something divided by n times omega 1, which I really hate. Now what if we do it the other way? A divided by n, C divided by n, so when we map it into the A divided by n omega 1 plus C divided by n omega 2, this already lies in the lattice because n divides C when we are in any of these. And A is a member of the multiplicative group here, because the matrix lies in gamma. And that means, yeah, what does that mean? This means that this generates the same. When we are down here, of course, A is equivalent to 1 modulo n, so it generates the same, it gives the same element. Up here, we shall show that it still has order n, and that's because it lies in the multiplicative group, so that there is t, so that at is equivalent to 1 modulo n, so it's still a generator of the same group. So I thought it should be omega 1 up here. I don't mind omega 2 here, but I really thought it should be omega 1 here. Now let's assume that we have shown the scaling is trivial, so this is the critical point. Let's assume we have shown that, and then f of gamma z equals f tilde of gamma z one. And then it's span and then whatever comes. Let's use gamma naught as example. That's 1 divided by n. That makes good sense. But then, yeah, then omega 1 divided by omega 2 lies in h, because z does, yes? Oop, yeah, omega 2 is still 1, yes? So we scale. Oops. Oh yeah. This is I don't think there's any need to go to f, by the way. That's just making things overly complicated. So we just whoa. I'm confused here. I just have to do it by hand and then I'll see what I can get. Hello again, Wednesday morning. I looked at it this morning and found out that I was very confused. When I did it this morning, I went directly from minuscule f to capital F. But now let's do it like they do in the book. See if I can find out about it. So the left-hand side, f tilde of, we'll write it up, a omega 1 plus b, c omega 2 plus omega 2, and c omega 1 plus d omega 2. And what this becomes, it depends upon the case we have. This one is simple. This one they did in the book, so we'll take the two other cases. And then gamma, omega, and then omega 2, and that's case gamma naught, or in the last case, and of course they span, these two span the same lattice, because our matrix gamma lies in, has determinant 1. This one is obviously okay. And then we need to check C divided by n is an integer, so it's equivalent to d omega 2 times z, but d lies in the multiplicative group, so it's a generator of the same sublattice, you can say, as omega 2. You just find the inverse in this group and multiply it by that, then you get the original one. So that shows invariance of f tilde, and then the operation of z the operation on z and f, so that's forward. Given a function f, capital F, we obtain a function minuscule f, defined this way, that transforms the right way. Whether it's differentiable on h is another question. Now going backwards, so the first step is from f to f tilde. So we've given a vector omega 1 point omega 2, and we must define the same way as we did in the book. And that's where we need omega 1 divided by omega 2 to lie in h. That will of course lead to f tilde being invariant under gamma, in the same group as f is. And then going back to f itself, we need to show that f scales correctly. But that's trivial. And then the rest follows as far as I can see without any problems at all, using what we already have said about how these transform. The last thing, this is of course 1-to-1, and this is the only one where you can say, do we have a problem here? No, of course not. So I don't see any problem. If I miss a problem dealing with gamma naught, then please write in the comments. But that's it for today.